Everyone, my name is Farah Nasyitah, and today I would like to present on my progress on my research, which entitled Reduction of Free Fatty Acid in Sludge Palm Oil using Glycerolysis as Biodiesel Feedstock. So basically, this is the brief of the study. So basically, biodiesel, which is commonly produced from vegetable oils as feedstock, usually used for source of energy. But then the origin for the feedstock, the cost is high. The vegetable oil is high in cost and somewhat unethical because it is edible. But then we want to shift from the fossil fuel to the renewable energy, which is biodiesel. So we want to promote the consumption of biodiesel. Therefore, we want to promote the utilization of using other material than vegetable oil, which we want to propose is starch palm oil that we collected from POMI, palm oil mill effluent. But then the SPO is low in quality. But it is an alternative for biodiesel feedstock because it is cheap and is renewable and it has the same constituent as palm oil. But then the drawback is the high FFA, because the high FFA, which is high free fatty acid, can cause formation of soap that is undesirable in the biodiesel production later on. Therefore, we will pretreat it first using glycerolysis. We have to reduce the FFA at least by 3% to it become feasible to become biodiesel feedstock. So when FFA decrease to become glycerides, SPO can be used as biodiesel feedstock by undergo trans-esterification to produce biodiesel. So yeah, that's it. So these are the problem statements. So the first one is the depletion of petroleum due to the high reliance as source of energy. The second one is utilization of vegetable oil as biodiesel feedstock that resulting in high cost of production, high amount of FFA in SPO that affecting in low yield of biodiesel, and common method of reduction of FFA using methanol has its drawbacks. These are the research objectives, which are the first one is to determine the physical and chemical characteristics of starch palm oil. The second one is to investigate the effect of temperature, oil to glycerol volume ratio, and catalyst loading to the reduction of FFA in SPO using glycerolysis. And the third one is to assess the feasibility of treated SPO as biodiesel feedstock by undergo trans-esterification. So basically, this is the scope of study, which we will utilize the waste, the SPO that we collected from the treatment plant in Kilang Sawit Bukit Bandi, Terengganu, and we will characterize to the SPO to prove its feasibility in qualifying SPO as an alternative as biodiesel feedstock. And the third one is we will do the esterification by glycerolysis using zinc oxide, and we will do the trans-esterification to produce biodiesel. Okay, so these are the research methodology for objective 1. We will use FTIR, HPLC, and GCFID. So this is for the objective 2, the experimental setup for glycerolysis, and hourly we will test for FFA by using the titration method. Okay, so this is the example setup. And next one is the research methodology for the objective 3. We will take the optimal result and undergo trans-esterification. So this is the first objective result. HPLC is still not done. We will done very soon. So basically, this is the summary of the result. Yeah. So this is the second objective. How we do the glycerolysis, and then the challenges is this. From reading material and previous study, it is significant to do certain parameters to analyze its efficiency and its optimal condition. The parameters were reduced to 3 values as it may reduce to significant hypothesis and discussion. For the model ratio, all ratio take 1 to 1 because it is no SS, 1 to 1.5, 50% SS, and 1 to 2, 100% SS. Okay, so these are the final FFA result. So basically what we can say is higher temperature give higher result, but that we necessarily have to take the lowest one because we just want the 3%. So for if you want for the optimum and economical point of view, I think we can take the this one 2.6 for 170 degrees C, which is lesser energy, but then excess in glycerol, and the catalyst loading is also 0.25% only. So these are the third objective, which is the biodiesel production by using trans-esterification. So basically this is the produced biodiesel. Yeah, we will do the decanting using separating funnel. Okay, so the conclusion is SPO has the potential to become biodiesel feedstock due to its promising characteristic, only need to improve its quality by reducing the FFA. Temperature contributes strong influence to the FFA reduction for glycerolysis. High amount of catalyst does not necessarily give better result. An ideal amount is sufficient. However, high amount of catalyst gives shorter time reaction. The FFA is lower at higher temperature, but higher than that will interrupt the process. Excess of glycerol help in reducing the FFA efficiently. Biodiesel can be produced from SPO with low FFA. So this is the Gantt chart. So basically, what I'm planning to do is using thesis writing and just a little bit in for the characterization. So this is the status of publication and thesis writing. Basically for publication, I have one published paper and two accepted paper that is waiting to be published. Thank you.